SwayamPrabha. Digital India. Educated India.
Hello everyone. So, we will continue with slash test data analysis. Here after slash test we get this type of time versus load plot, and from this plot we can get the peak force during the slash. Here it is 27 kg and the slashing time it is 36 millisecond. So, based on this data we can get the performance slash performance. Now, we will discuss specific case study, the slash resistant performance of woven fabrics. Now, here we have developed different types of yarn structure. This yarn structures made of 3 layer structure. At the core we have filament. This core yarn either stainless steel or glass core. In the second layer the polyester is used, staple polyester, that is in here it is in S direction, in this case also S direction, and in the outer sheath, outer layer ultra high molecular weight polyethylene, one is in S direction, another is in Z direction. These yarns were used to produce different types of fabrics. Here with the microscopic analysis we can see clearly the presence of stainless steel at the core, high performance polyethylene at the outer layer and polyester in between. This is for stainless steel, and for glass you can see the glass core. This is the glass core filaments are there, and polyester, this is a polyester in filament form was used, and HPP. So, HPP, so high ultra high molecular weight polyethylene, that is used in the outer core. So, microscopic picture clearly shows the structural integrity. In the structure all the fibers are present at different level, and the yarns which were developed. So, yarn 2 and yarn 5, yarn 2, yarn 5, yarn 8 and yarn 11, they are made of the high hard particle impregnated yarn. So, that same yarn were used for cut resistance. So, hard particle impregnated yarns. So, glass core it is 30, 40 and 50. So, Y 2 and there is Y 2 and Y 2 HPP. So, there are different types of this high performance polyethylenes are used here. So, Y 2 HPI means high performance high hard particle impregnated, and Y 2 is simply the without hard particle impregnated. So, here we have used different combinations, and for hard particle impregnated 300 denier with and without hard particle impregnated, this filaments are used, and polyester was 100 denier filament, and twist per meter was kept for all the specimens, and only the twist directions were changed for the outer layer. From the all the 16 yarns which we have developed, so we have developed 16 fabrics were developed. So, keeping the thread density with ends per centimeter kept constant for all the fabrics, and to maintain the this aerial density at the range of this 160 to 215. So, we have varied the peak density, and for glass core almost similar, little bit higher range was higher level of this GSM was obtained, and bulk density were calculated, and from this 16 an oven fabric, plain oven fabric, we have tested the slash resistant testing. So, the possible highest thread density was selected for making the most compact fabric structure. So, this from all this we have tried to produce the possible highest thread density, because for slash resistant test slash resistance we need very compact structure. So, why compact plane structures were produced? So, hypothetically slash is a combination of stab and cut action, and for generating protection from initial stab thread a compact structure is required. So, that was our hypothesis, that is why we have developed a compact structure. Now, slash resistant testing. So, automatic slash tester was used, that we have already discussed in last session. So, home office slash resistant materials were used in this tester. So, here two levels SR1, SR2, different levels that we have already discussed, where the energy required is 36 plus minus 2 joules. Then we performed the cut resistant testing of all these fabrics using TDM 100 for ASTM level. So, different types of ASTM levels were there from A1 to A9. This we have discussed earlier in cut resistance, we are not going to discuss here. If you want to know the detail of the cut resistant test, you can please refer to the module in the cut resistance testing. Tensile strength test, strip tests were carried out using Instron UTM. So, strip test was selected because it requires smaller sample size. So, ASTM test standard was used to test the tear strength. Here we can see the tearing characteristics of this developed fabric. This is the tear strength testing. Trapezoidal tear strength testing is carried out. Okay. Now, fabric is damaged here. Now, trapezoidal method was used to, because tongue or leaf method showed slight tear. So, that is a yarn slippage was there. Then abrasion testing was done as per ISO standard. This is the abrasion here. Now, here you can see the abradent surface that gets actually worn out. So, weight variation was observed after 1000, 2500, 5000 and 10,000 cycles. So, automatic slash testing. So, why two load cells were used? Two identical load cells. So, two identical load cells were positioned at as shown in this diagram to obtain the accurate data during the strike. This is the developed instrument. Here is the load cells and fabric support here. So, how does the drop height selected here? So, 1.8784 we have selected. So, drop height was selected in back calculation, keeping the required energy 36. The energy calculation is the energy, height, weight and G. So, mgh is the energy. So, sabot weight is known 2 kg and we know the gravitational acceleration, which is 9.81, and required energy is 36 as per the standard. To achieve 36, we have to manipulate the height. So, from there if we calculate, so we get the height 1.84. So, accordingly we have selected this height. If we change the weight, we can change the height also. Now, slashing time and force. Now, this is the table we get after the test. So, when the test start and sensor will start sensing, and then the load cell will start sensing the load, and this is the type of sensing. Now, here we can see that false, false, false and then true. True means when the metal, there is a electrical connection, there is a perforation is there, that will tell that this is the true value, and when there is no false, the no perforation, then it is a false, although there is a force applied on the fabric by the that knife. This is the perforation time and force. So, the load 5.87 is 5.27. This is the load when, and it shows the true, that means at this point the perforation has started. And fast penetration time and force there, that is a true. Then the it has penetrated, it is going through, and then there will be peak penetration time and force. So, peak penetration force is it is 25.12 kg peak force. So, this is the 25.14 and peak penetration time is 36. This is the 36 penetration at this point, 36 millisecond. So, here we can see 36 millisecond. After that, then again there will be false. So, after that we do not need to get the data, that means load has reduced. So, slash induced time is that peak penetration time, which is 36 second, minus fast penetration time, that is 33 millisecond, that is slash induced time, and slash induced force is that peak penetration force minus fast penetration force, that is the slash induced force. So, these two data will actually tell the slash performance, and cut through distance is the that we can calculate. Now, here it is a initial impact point, that is the initial impact point, and the slashing point for this fabric, it is the slashing point here, here it is the slashing point, and initial impact point is this one. And the point at initial impact point and the slashing point, it is known as the cut through distance. That means, that distance, after that the first penetration will start. So, that means that is the that shows the resistance of the protective textiles. That means that it is not allowing the knife to penetrate through that. That cut through distance, the slashing point minus the initial impact point. The higher this cut through distance means better will be the protection. Now, here in this curves we see that penetration time for both this SS core and glass core, and this curve is for warp, here is for weft. And this yellow highlighted data are with the this hard particle impregnated yarns are used. So, from here we can see, and this is the black dots are fast penetration point and fast penetration time, and red dots are the peak penetration time. So, here we can see that penetration time, fast penetration and peak penetration time here. So, high particle impregnated SS core fabric shows the highest penetration time for both initial penetration time and peak penetration. You can see these are the highest penetration time, and for this both. And in glass core fabric, if you see this is glass core and this is the enlarged image for this. In glass core fabric, this type of effect of the SS core is absent. This may be due to multi filament glass fiber in the core, and which may get fractured quickly, and also overall the penetration time is low in case of glass, and it will be as along with the other SS type of fabric. Apart from this hard particle impregnated this filament, other filaments without hard particle, the performance of glass core and SS core are almost same, there is no significant difference. This is true for both warp and weft. In weft also, the hard particle impregnated this filament is giving very high penetration, fast penetration time or peak penetration time. So, that means the here along with the, as we have seen in the cut resistance, here hard particle that impregnated filament is showing very good this cut slash resistance, good indication. So, non HPI samples, the samples without any hard particle for both SS and glass core fabric show similar kind of penetration time both in warp and weft, that I have already mentioned. And penetration time in other angle. So, we have seen warp direction and weft direction. In 45-degree angle, 45-degree angle, there is no such trend available. So, in 45-degree angle HPI has no such effect like previous, because the fabric jamming during the slashing plays a vital role here. So, here fabric actually jamming takes place. So, that is basically dominating here. Potential energy due to the interlacement of woven fabric causes the fabric jamming at 45-degree. So, if you see the overall, in overall the trend we get in average, the SS core is giving higher this fast penetration and for a peak penetration time with the HPI coated, HPI treated, HPI high particle impregnated fiber. The overall result of slashing time, HPI has significant effect which comes from the warp and wave direction mostly for SS core fabric, stainless steel core fabric. Now, coming to the penetration force for this SS core and glass core in warp direction and wave direction. Here if we see that, and also fast penetration and peak penetration, there is no such significant effect of this hard particle impregnation on penetration force. So, penetration force reduces with yarn diameter increases, and fabric, that is, as the yarn diameter increases, penetration force reduces and the fabric thread density decreases. So, that penetration force is basically is higher when the fabric becomes compact in both warp and wave direction. So, as the yarn is thicker, so we have to use the less thread density. So, that is actually the reason for reduction of the penetration force, and glass core fabrics have higher fast penetration force than SS core. So, we can see the glass core has higher penetration force. At 45-degree glass core fabrics show higher slash force due to having the multi filament on it, but in case of SS core we have single filament. Overall the initial slashing force is higher in glass core yarn, and slashing force reduces with the reduction in thread density. This is the overall trend. Slash induced time and force. This is the SS core, glass core, slash induced time. These are the slash induced time, and the dots are slash induced force, warp direction, wave direction. So, the glass core fabrics have lower slash inducing force than SS core. We can see glass cores have lower slash inducing force than SS core has little bit higher in both warp and wave direction, and warp slashing force. So, the slash inducing force were higher than the waved having higher thread density. At 45 degree, and this is for average. So, mixed observation were observed at 45 degree. Overall, the slash inducing time for all samples were nearly same. You can see the slash inducing time are almost same, but the inducing force was higher for SS core fabric than the glass core fabric. So, here overall if we see, overall force is higher than the glass core fabric, but they are all within the certain range. Now, cutting through distance, these are the cutting through distance. The warp way cut through distance was higher than 45 degree angle and wave way cutting through distance. Overall, the SS core fabrics have higher cut through distance, okay, than the glass core, than the distance of the glass core fabric. HPI hard particle impregnated fabric shows elevated cut through distance for most cases. We can see here, this is the HPI. So, in most cases cut through distance are higher. Now, cut resistant testing, we have seen the HPI, that high hard particle impregnated fiber gives higher cut resistance, that we have already seen earlier. Coarse core yarn higher cut resistant value. So, that is if we use the coarse yarn, so it will give the higher cut resistance. HPI significantly increases the cut resistance with respect to the corresponding non HPI fabrics. Similarly, we have seen the slash resistance, the tensile performance here, the tensile stress. HPI significantly reduces the tensile strength for having thick thin places on the fiber. Warp tensile strength was higher due to having higher thread density. Now, tensile modulus. Now, with hard particle impregnated fabric, the tensile modulus is reduced as compared to the non hard particle impregnation. Tensile modulus was found to be more than 600 megapascal for all the samples with maximum 1370 megapascal. So, this tensile modulus was very high. So, SS core fabrics show a bit higher modulus than the glass core, little bit higher, but these are acceptable range. Tear strength. So, warp weight tear strength was found to be higher than wave weight tear strength. SS core shows higher tear strength than glass core, and HPI fabrics shows lower tear strength. Similar trend was observed earlier also. Now, abrasion resistance. So, for any protective textiles the abrasion is very important. Now, here we can see very low weight variation was observed during abrasion resistance test. So, that means the fabric abrasion did not happen. It was all the fabrics were found to be highly abrasion resistant. HPI fabrics showed higher weight variation than non-HPI fabrics due to having rough surface. So, if you see here the HPI treated fabrics, they are showing higher weight variation when we are testing at different cycle. So, 0 to 1000 cycle, this is 0 to 1000 cycle. Here there is no weight variation, 1000 to 2500 cycle. There is high weight variation here, then after that it is lower variation, then 2500 to 5000 and 5000 to 10,000 there is a negative weight variation. That means, it is actually damaging the abradant fabric. So, that means standard fabrics was damaged, it is receiving the weight. So, weight variation, that it is damaging due to the hard particle present, due to the rough surface. So, the same trend was observed in other fabrics also, not only this hard particle, other fabrics also, because this fabric structure, that the outside that it is a ultra high molecular weight polyethylene fibers were there, these fibers are very tough, okay, high modulus, high strength. So, that fiber itself was damaging, particularly at higher cycle, that was observed. So, this is the abrasion resistant data after 10,000 cycle. No fabric deformation, hole or yarn breakage or was visible because of the special structure of yarn. Now, the surface morphology of the blades, the blade tips were studied before and after the slash. Now, before slash we can see the tip was very sharp tip, and the blade tip after the slash you can see this is blunted. After slash the blade tip was there tested, there is a completely blunted, and here the fibers surface was tested. Here you can see that hard particle impregnated fiber, and so blade tip breakage confirms that friction among the blade tip and fabric, and also with the copper bar, that is sensor copper bar. So, where we can see there is a traces of coppers are there. So, that blade damage was there. So, EDX confirms the presence of hard particle, that is tungsten is there, this is the W, and ACM confirms the deformation of fiber due to the hard particle impregnation. So, here the fibers are deformed. So, the overall conclusions are the both fabrics pass SR2 slash resistant levels. So, both the this core, glass core and stainless steel core. So, all the fabrics they pass SR2 level of standard. Hard particle incorporation in ultra high molecular weight polyethylene fibers improve the slash resistant performance. SS core and glass core yarn showed nearly similar kind of slash resistant performance. Initial penetration force was higher for glass core fabrics than SS core fabrics. SS core fabrics need higher induced force than glass core fabrics. SS core fabrics need higher induced slashing force than glass core fabrics. So, these are the overall conclusion of our study, but this overall this is the only a single study, and but what we tried to give some glimpse, some idea to develop different types of slash protective textiles. So, we have come into conclusion, the end of the this mechanical thread protective textiles. So, cut resistant performance level is A4 level we have got. The tensile strength was found within the range of 100 to 150 Newton for non HPI. However, HPI reduces the tensile strength to 60 to 80 Newton. The warp tear strength was higher than the web tear strength due to having higher end density. All samples were highly abrasion resistant, negligible weight loss was obtained. So, now we have finished the protective textile for the mechanical thread, and in the next session we will start a different level of protection. So, we will discuss the protection from sound pollution. So, what are the different types of threats related to the high sound, what are their our impact on human health, and how to protect, how the textile materials can prevent that block this type of sound pollution. So, this we will discuss in the next session. Till then, thank you.